Okay, solving literal equations. When I think of literal equations, I just think of regular equations. So I'm going to set up an equation here that we're going to solve, and then I'm going to mimic that with what a literal equation actually looks like. So let's say we have the equation 3x minus 6 equals 18. So if we were solving this, the first thing we would do is add 6 to both sides. That leaves 3x is equal to 24. We got to get rid of the 3, so how do we get rid of the 3? We divide by 3 on both sides. And then that would leave us x is equal to 8. Now, all a literal equation is the exact same thing, the difference mainly being that we typically don't have as many numeric values. We usually have more variables. So when you're solving it the same way, you just end up with more variables in the answer. So I'm going to take one that looks very, very similar. So I'm going to say 3x, but this time I'm going to say minus 6y equals 18. Now the difference occurs right here. I still go through the same process. Plus 6y plus 6y. So I'm still trying to, in this case, get x by itself, much like I did over here. So when I go ahead, simplify, these are going to cancel. Over here, though, I cannot add 18 and 6y. Those are not like terms. So all I do is I write the expression. So I have 3x equals 18 plus 6y. What was the next step over here? I divided by 3. Well, to get x by itself, I got to do the same thing here. So I'm going to divide by 3. The difference is on the right-hand side, I've got to divide all of it by 3. Same thing, those 3's cancel. That's going to leave x. The difference is now on the right-hand side, I'm going to be left with an expression. Now I can simplify. 3 goes into 18 6 times. 3 goes into 6 2 times. So the 3 will cancel here, and that gives me 6 plus 2y. If that didn't really make sense to you, you could have also thought of it like this. If you have 18 plus 6y divided by 3, really what you're doing is 18 over 3 plus 6y over 3. And then if you simplify each of those, that's how you end up with this. So let's take a geometric formula and let's work the geometric formula trying to solve for a particular variable. So there's a formula for area of a trapezoid. Area is 1/2 height times base 1 plus base 2. So in this particular case, let's solve for h. Now this is key. You've always got to know what variable you're exactly solving for. Again, I do not like fractions, so I always try to get rid of them. So how can I get rid of this 1/2? Well, really, you can think of it two ways. That's dividing by 2 or multiplying by 1/2. So the opposite of that would be multiplied by 2. So it's going to cancel those. So now on the left-hand side, I have 2a equals h times b1 plus b2. Now, since it is h I'm trying to get by itself, I'm going to get rid of everything that's with it. So in this case, again, I have multiplication. What's the opposite of multiply? That would be divide. So I'm going to divide this side by that whole expression here, b1 plus b2. Well, again, whatever I do to one side, I got to do the other. So I take this side and I divide it by the expression b1 plus b2. These will now cancel. Now I have h isolated. 2a over b1 plus b2 equals h. And now I've solved this literal equation. Now again, the purpose behind this is that you can rewrite formulas, especially when we're talking about geometric formulas. when you have multiple problems to solve for a specific variable. In this particular case, we were solving for h, which is height. So we have some other examples here of problems that we are given. Solve each little equation for the given variable. So as you read the problem, we want to look right here. So this one wants me to solve for x. So if I bring this over, y equals x plus 12, it wants me to get x by itself. So how do I do that? I got to get rid of the 12 by subtracting. And again, the difference is going to be you're not going to get a numeric answer here. You're going to get an expression, which is just y minus 12 equals x. And then we have that one simplified. Let's go ahead and do one more example here. So let's look at this problem number 8. It says William got a score of Q1, Q2, and Q3 on 3 quizzes. Write a formula for the average. Okay, so average is you add them all and divide by the number you have, in this case 3. So that would be part A. Now, what it says is what formula can William use to determine the score he needs on the 3rd quiz to get an average of 90. Okay, so what we want to do is we want to isolate this variable, Q3. Well, again, I have a fraction, so the first thing I want to do is get rid of that. So I'm going to multiply this by 3, multiply this by 3. If I do that, those cancel. So now I have 3a equals Q1 plus Q2 plus Q3. Again, I want to get Q3 by itself. So what I'm going to do next is I'm now going to subtract Q1. So those will cancel. So now I have, I'm going to write underneath this here, 3a minus Q1 equals Q2 plus Q3. Then I get rid of the Q2 by subtracting. Again, those cancel. So now I'm left with 3a minus Q1 minus Q2 equals Q3. Now for the problem, they gave me 2 of the quiz scores, and we want to get an average of 90. So all I'm going to do is plug each of those in for their appropriate values. So now I have 3 times the average, which is 90, minus Q1, which was 85, minus Q2, which is 88, and that's going to equal what I'm looking for in this case, which is Q3. So now I just type all that in on my calculator, and if I do that, then I'm going to get 97 equals Q3.